Hi students, we are continuing the work per energy problems. So this is the mass of 2m and this is the mass of m. Okay. Now our question is the 2mg is displaced over s meter. Okay. Okay. Find the work done on the entire system. Net work done on the entire system. Okay. So it will be easy, and let's draw the free body diagram. Work done by the tension. The general question can be asked. Work done by tension on 2m mass. Okay. So let's draw the free body diagram. 2m 2mg, upward force is tension. So instead of doing in this way, I will do directly. How much is the net force acting 2mg? A is equal to net force over mass. What is the force acting 2mg? There is no opposing force in the mkg. So m2 mg over total mass 2m plus m, 3m. Acceleration is equal to 2g over 3. And a is equal to, in which direction it is? Downward direction. 2g over 3 in the downward direction. Now the displacement is equal to s is equal to half ut, to u is equal to 0, half gt square, and tension, the displacement is also in which direction? Downward direction only. Half g, sorry, half, I'm sorry, it's not g, half at square. A is equal to 2g over 3 into t square. So displacement vector is, we got the displacement vector. The work done is equal to tension t bar dot s bar. Okay, what is the angle? This is the tension in the upward direction, and the displacement in the downward direction. What is the angle? 180 degrees. I am writing ts cos 180, and t, do we know the t? We don't know. We should find. S is equal to how much? Half 2g over 3 into t square, and the cos 180 becomes minus 1. T we need to find. What is the t? We can get it from the equation here, from the free body diagram. 2mg minus t is equal to 2m into 2g over 3 to mass into a. Then the t is equal to the 4mg, 6mg minus 4mg over 3. It is equal to 2mg over 3. This is the tension. Now the tension is equal to 2mg over 3 and half 2g over 3 into t square, and the minus sign will be there. Minus gets cancelled, and 2 gets cancelled. Minus 2 over 3 mg square. 2 over 3 9, 2 over 9 g square. T square will be the value for the work done by tension. Net work done, total work done is equal to how much? Now total work done is equal to sum of all the forces into displacement. What is the sum of all forces? Sum of all forces is, tension is an external force or internal force. If we add, this is a plus t and a minus t on the both sides, plus t and minus t. Tension will be internal force. Okay, tension gets cancelled. So the force is equal to 2 mg multiplied with displacement is equal to half 2g over 3 into t square. This is the formula for work. This is the expression for work done by total work done. Okay. Now in the previous cases we will discuss one more question based on this. There is a pulley on the mass m1, m2. Find the work done to move displacement of s. Okay, m1 is greater than m2. So this is another example. First, to get the work done, total work done, okay, total work done. So whenever you see this kind of arrangements I discussed in my previous videos, just take it as a rope on a horizontal line, m1 m2. What is the force on this side? m1g m1g. On the left side it is equal to m2g. And yeah, net force is equal to m1 minus m2 into g. And how much is the displaced? Yes, so work done is equal to force into displacement. Force in the m1g is greater, so m1g in the downward direction, displacement also downward direction. It's into yes, so s into m1 minus m2 into g is the work done by, total work done by the force. Okay, this is a total work done, it's not a work done by the tension. So the work is, find the work done by tension on m1 and on m2. Okay, and find the work done on the netto, sum these two, add these two. Work done by tension on m1 plus work done by tension on m2. If you do properly, you should get answer 0. Okay, next, see this question. This case, there is a man standing, he is applying a force and it is displaced d meter with a constant velocity. Velocity is constant. Velocity is constant. Find the work done by tension on block of mass m kg. Okay, now how much is the man applying the force F? What will be the tension? If the rope is massless, tension is equal to force. Okay, tension is equal to force. Now if you draw free body diagram of block, upward force T and the mass m, downward force is equal to mg, T is equal to F. How much should be, acceleration is equal to 0. How much should be the force? Force should be equal to mg. Understood? mg. How much is the displacement? Displacement is in the upward direction. Work done by tension is equal to tension into displacement d cos theta. How much is the angle? Displacement in the upward direction, tension in the upward direction. Angle is 0. T is equal to mg and d cos theta, it's 1. What is the work done by gravity? Work done by gravity, mg, force in which direction? Downward direction. In which direction the body is moving? Upward direction. What is the angle? 180. mg into d, and cos 180 is equal to minus. Sum these two, add these two. So total work done is equal to how much? 0. So if a body is moving with a constant velocity, total work done is equal to 0. It doesn't mean each individual work done is also equal to 0. In this case, work done by tension is positive, work done by gravity is negative, and the positive negative both got cancelled. Okay, now let's see the second part of the question. Next question, that now both the body is moving with a constant velocity, say constant velocity is equal to constant, and what is the work done by tension on block? Work done by tensions on the block. So this is a work to you, how much force is acting, that you should get it. Okay, let's do one question. There is a lift, and lift, man is standing, and it is going upwards with the acceleration a. Okay, with the acceleration a. Lift is going upwards with the acceleration a. A man of mass small m, lift of mass capital M. how much is the work done by normal on man as a function of time. So if you draw the diagram carefully, free body diagram of man, so nothing to worry in this case. Even the lift mass is given, don't be panic. Mass of man is m. How force will act? Mg is one of the force acting in the downward direction. What is the other force? Normal force is acting in the upward direction, is accelerating in the upward direction. Okay, now n minus mg is equal to ma. The normal force is equal to m multiplied with a plus g. This is a normal. Now what is the question? Work done by normal as a function of t. Now this is started with as uniform initial velocity 0 and s is equal to ut plus half gt square. Now u is equal to 0 and half g t square. G, it's not, oh wait a minute, I'm just writing wrong. Half at square, I'm sorry, half at square, half, it's going upwards with the at square. Let's write the expression. Work done is equal to normal n bar dot s bar is also equal to ns cos theta. Normal is equal to m into a plus g and the displacement is equal to half at square, and the angle, both are normal is also upward direction, acceleration also and displacement also in the upward direction, so cos 0. This is the work done by normal. Okay, work done by gravity. Work done by gravity is equal to downward force mg and displacement is equal to half at square. And what is the angle between mg and displacement and our acceleration? 180 degrees. It becomes minus mg. Total work done is equal to work done by normal plus work done by gravity. Okay, work done by normal plus work done by gravity. Okay, now there is one question in a Singage. That question, there is a rope, over a rope a man is climbing, man of mass m is climbing upwards with a constant velocity v. Mass of the man is m, is going upward with a constant velocity, and find the work done by the tension. How much work he is doing to climb up. Work done by tension and work done by gravity. So let's write it. If you draw free body diagram of man, he is upward tension T and the downward direction mg, and acceleration is equal to 0. The tension he is applying is equal to mg. Instead of man, they can ask an insect is crawling upwards. Insect is crawling upwards with a constant velocity v, or the same like the previous cases. Okay, so t is equal to mg and s is equal to, what is the velocity? V into t. Now work done is equal to force into tension into displacement. Tension in which direction? Upwards. Velocity or displacement in which direction? Upwards. Ts cos theta is cos 0, it's a 1, mg multiplied with vt is work done by tension. Work done by gravity is how much? Work done by gravity, mg is in the downward direction, vt is in the upward direction. Angle is minus mg vt. Total work done is equal to how much? 0. When the bodies move with the constant velocity, the work done is equal to 0.